Hi, I'm Ashton Lewis. I'm the technical product manager. I think that means like geek in charge at RahrBSG. And here I want to talk about Fermcap S and Fermcap AT. These are two really exciting topics, so buckle your seatbelts today. So what are Fermcap S and Fermcap AT? Well, they're both versions of polysiloxane. That's a mouthful. And that is an anti-foaming agent. We also have a new product called Fermcap Eco, and Fermcap Eco is a plant-based version of the anti-foam. But all of these anti-foams fall under the umbrella of Carry Fermcap. So Fermcap S, Fermcap AT, and Fermcap Eco are all anti-foams that we sell through Carry. So why are these products used? Well, they're used actually for a lot of different reasons. In the brew house, we use Fermcap as an anti-foam and wort boiling. And there are a few reasons to have an anti-foam and wort boiling. One is for safety, because overboiling kettles is dangerous. And that's no laughing matter. You can really have a bad brewery injury, a burn, if a kettle overboils. So one of the reasons for the use of Fermcap in the kettle boil is to prevent foaming that can occur, which results in danger. Another effect of actually adding the anti-foam allows you to get more utilization out of your kettle. Most kettles are designed with at least about 30 to 35% headspace, which seems like a lot of extra space, but it's there for a reason. And because it's there and it seems like it's excessive, a lot of brewers are tempted to overfill kettles, and that's really where the safety problems begin. So the safety is one of them. Another reason for using an anti-foam in a kettle is that foaming during wort boiling is one of the causes of loss of hop utilization. So hop utilization is defined as the amount of alpha acids added to wort compared to the amount of isoalpha acids present in beer. And anything we can do to reduce foaming during the wort boil will get more of those isoalpha acids into your finished beer that result from the isomerization reaction in the kettle. So we've got safety, we've got utilization, and we've got headspace or reasons that we use the anti-foam in the kettle. Now, if we take that into the next part of the process, fermentation, we also use anti-foams in fermentation. Like the brew kettle, one of the reasons for adding the anti-foam in fermentation is hop utilization, because we're also losing isoalpha acids in the fermenter, because the isoalpha acids they tend to partition into the foam, and if that foam sticks to the inside of the fermenter, then we lose some of those isoalpha acids during fermentation. Another thing that happens during fermentation is the dreaded blowover. And this drives me crazy when you walk into a cellar and you see foam going down the drain. And the reason that drives me crazy is that foam represents money. So literally money is going down the drain. That's an economic loss. The other thing that's going down the drain with that foam is BOD. So biological oxygen demand is one of the measures of how dense your effluent is. And if you have high beer foam losses during fermentation, that's just unnecessary waste going down the drain that's going to have to be treated. So we've got hop utilization, we've got reduction in effluent. Another key thing with that anti-foam and fermentation is that the fermenter, just like the kettle, typically has more head volume than technically required. So most beer fermenters contain about 33% of the total volume of that fermenter is devoted to headspace to allow foam to form during fermentation. Now that number really kind of changes depending on the particular yeast strain. Some yeast strains foam more or less than others. That's an average on how fermenters are designed. So if you use an anti-foam, you can effectively gain capacity in your cellar without adding any equipment whatsoever. Simply use the anti-foam, put more wort in the fermenter, and generate more beer. The fourth reason, and yes, there's a fourth very distinctly different reason for using anti-foams in fermentation, is CO2 collection. Now, if this video were recorded 5 years ago, most of you watching this would not even be considering CO2 collection in your cellar. But with the development of CO2 collection technologies that are applicable to smaller breweries, this is a very real topic. And one of the reasons why anti-foams help with CO2 collection is that when foam forms during fermentation, it inhibits a clean break between air and CO2 when you're collecting the gas that comes off the fermenter. So by using an anti-foam, you get a cleaner break between the air that's in the headspace in the fermenter and CO2. And the reason that's important is that CO2 collection systems are designed to reject high oxygen gas. So they actually wait until the CO2 content meets a specification before going into collection mode. so you get better collection of your CO2 when you're using an antifoam. So a lot of different reasons of using an antifoam. The crazy thing about antifoam is that so many brewers have this negative perception of antifoam. And one of the negative perceptions that's really persistent is that antifoam added to your fermenter or to your wort is bad on beer foam. Now, for people that know me, I'm kind of a foam geek, like hardcore, and I really don't like to do anything to beer foam that's going to be negative. Well, the thing about antifoam is it actually helps beer foam. Why does it help beer foam? Well, beer foam is kind of a one-trick pony. Once the beer foams, the proteins that are involved in the foam are lost from the beer forever. So if we can prevent the foam from ever forming during fermentation or during wort boiling, we actually preserve more of those foam-positive proteins that are going to survive in your finished beer. So that is not a concern. So there's a lot of reasons to use antifoam. The usage rate for Fermcap Eco or Fermcap S/AT, they're all the same. They're in the range of 10 to 80 parts per million, and that range is dependent on the kind of beer that you're brewing. So with other process aids, it's important to do some empirical plant trials to figure out what works best, but that's the range you're going to be using, 10 to 80 milligrams per liter. So if you have any questions about Fermcap Eco, Fermcap S, or Fermcap AT, please reach out to your RahrBSG sales manager, your CSR, your customer service rep, or contact me, Ashton Lewis, directly. Cheers.